Okay, in this video, we're just going to learn how to find the sides, the lengths of the sides of special triangles. The first is the 30, 60, 90 triangle. And because there's a specific pattern for the length of the sides in this triangle, it's very easy to just get one side of the triangle and find the other two. So this pattern says, if we know the side opposite the 30-degree angle is called x, the hypotenuse will be twice x, 2x. You could also think about it as whatever the hypotenuse is, we divide by 2 to get the little side, the leg that's opposite the 30-degree angle. And then the longer leg, the one that's opposite the 60-degree angle, well, that's going to be whatever this x is times the square root of 3. So let's try it. So suppose I say that x is 4. Well, then my hypotenuse will be 8. 2x and x. And the long leg opposite the 60-degree angle will be 4 times the square root of 3. As you can see, I didn't really have to work very hard on this. I just had to apply the pattern. Let's try another one. So suppose my short leg is 11. Well, according to this pattern, my hypotenuse has to be twice that, 22. And the side opposite the 60-degree angle has to be 11, short leg length, times the square root of 3. This pattern holds no matter what numbers I start with and no matter where I begin. So let's try starting with another value. Let's start over here and let's say that this leg, the length opposite the 60-degree angle, is 7 times the square root of 3, corresponding here. So if 7 times the square root of 3 is x times the square root of 3, then the 7 must be the x. And once we have this pair of sides, we know that the hypotenuse is twice this short side. It's 2x to the little x opposite the 30-degree angle. So this is 14. Okay, let's try another one. Let's say that the hypotenuse is 92. Well, we can divide that in half. You might have to use a calculator, but many of you may know that the half of 92 is 46. And it doesn't matter that this is big. We still multiply it by the square root of 3 to get the long leg. Okay, let's try something a little different now. Let's say that we're given that this tall leg is 12. Now you look at this and you say, well, that's a problem because it should be something times the square root of 3. Well, it is something times the square root of 3. We have to find the something. So let's just set them equal to each other. We can use our algebra. X times the square root of 3 has to equal 12. What's x? Well, square root of 3 is just a number. Just divide both sides by the square root of 3. This will expose x. And this is the value for x. It looks a little strange. X is 12 divided by the square root of 3. But what's important here is our relationship between the lengths of the sides is the same as it is here. If I multiply this side, the length here, opposite 30 degrees, by the square root of 3, I'll get this other length, 12. Now I still have to keep the relationship between the short leg and the hypotenuse. So I have to multiply this by 2, and that would give me 24 divided by the square root of 3. So you see, no matter where we start or what value we're given, This pattern tells us how to find the sides of any 30, 60, 90 triangle. Okay, well, 30, 60, 90 triangle is not the only triangle that we call special. We also have the 45, 45, 90 triangle. This triangle is even easier to understand because this is an isosceles triangle. The base angles are congruent, so the two sides opposite those angles are congruent. And all you have to remember is that if one of the legs, one of these perpendicular legs is x, the hypotenuse is x times the square root of 2. So if this leg is 6, this leg will be 6. They're congruent. They're opposite the 45-degree angles. And the hypotenuse will be 6 times the square root of 2. And we can come up with very different numbers. Let's say the leg is 707. I'm making it hard for myself to use this tool that I'm using. Well, still the hypotenuse would be 707 times the square root of 2. Okay, now let's just make it a little bit interesting. Let's say that the hypotenuse was 18. Well, that's a little problematic because it's supposed to be something times the square root of 2. Well, it is something times the square root of 2, but what is the something? So we use our algebra like we did before. X times the square root of 2 in this weird situation is 18. We want to solve for x, and the square root of 2 is a number, so we can just divide by that number. So what you see then is we found the something that when you multiply by the square root of 2, it gives you a hypotenuse. So the legs are 18 divided by the square root of 2 when the hypotenuse is just 18. That's the unusual case. As you can see, this is pretty easy. 7 times the square root of 2, the legs will be 7. You can get all these problems done now.